Alrighty, so diving more deep into what is a dilation, okay? The most important part is probably the beginning, is where do we start with the dilation? We start at a point, usually somewhere, and we call that the center of dilation. So if I start with that pink triangle there, everything flows from that center of dilation on the left, okay? So just like over here, I've got the center of dilation. Everything flows out from there. If I make my scale factor really, really big, or if I make it even negative, everything flows from this point right there. So everything gets closer or farther away from a center of dilation. The distance specifically is determined by the word I just said a second ago, which is called that scale factor. Okay, it's if you've maybe heard the term scaled up or scaled down before, the scale factor determines how big our new shape is going to be. Okay, here's a little diagram right here. We use the word pre-image in the past as like the original, and then the image as the new thing. Okay, again, pre-image just means the original, and image just means the new after the dilation. So if we're looking at specific triangles here, and I want to name the pre-image, that would be triangle. I'll just call it ABC, triangle ABC. And I've been saying the phrase be consistent. If I started with A, let's start with the point that corresponds with that. That would be A prime. Remember that little tick mark means prime, B prime, and C prime. So in a dilation, it's either a reduction or an enlargement. Since this got bigger, this is an enlargement. Okay, enlargement. And the way you can maybe remember that is it got bigger. Alrighty, so moving on, at these specific distances. So when I deal with the dilation, what also is interesting is the lines that came out from it. So these dotted lines are what I'm about to talk about right now, all these dotted lines here. It says O to A prime. If I look at that distance, O to A prime, that's down here. That entire distance is going to be 2.3 plus 4.6, which is going to be 6.9. So I'm going to go ahead and put that in my ratio up here. O to A prime is 6.9, that whole thing there. And then O to A is 2.3. Now, if I divide those things, because it's a ratio, I should get 3. Let's see if that keeps happening. So O to B prime, that's going to be this distance here. That's going to be an entire distance of 6 on top. And then O to B is just 2. And what do you know? 6 over 2 is 3. Let's see if the same thing happens for O to C prime. That's this big long one here. 4.3 to 8.6. That's going to be 12.9 divided by that original distance from O to C. That'd be 4.3. And again, what do you know? I get an answer of 3. So what does this mean for my scale factor? What did I multiply by to get those new distances? I multiplied by 3. So we've used scale factor in 2 different ways now. Scale factor is used to talk about the sides. If I just said that the scale factor was 2, um, A to B is half of A prime to B prime, or A prime to B prime is double of A to B. Okay. Now, what's also going to be true is that O to A prime is double of O to A. So there's 2 things that are doubled. It's the sides of the triangles and the lines through that center of dilation and those vertices. So there's 2 things that the scale factor would double or triple if we're looking at the same exact situation in this case. But this is going to be off the page, so it'll be kind of not as helpful. This briefly came up the other day. Um, looking at the angles of dilated shapes, notice I've got a 74 here and a 74 here, a 40 there and a 40 there, and a 66 here and a 66 here. So, if we remember from earlier in the year, we said AAA doesn't prove congruence all the way back from Unit 4 because what do you know? It's a dilation. Okay, so that's where this comes up again. Okay, that's why if you have an AAA where all three angles are congruent, what's nice is we can say that we know this is a dilation. So again, we know that these angles are congruent. And again, it's that little equal sign with the tilde on top. And then therefore triangle ABC is similar to triangle A prime, B prime, C prime. Test yourself what goes in between those. Not this symbol, it's just squiggly line. Okay, that's saying that those two triangles are similar. Like I showed over in this example right here, um, the the dotted lines through the center of dilation are affected by the scale factor, and the side lengths of those triangles are affected. So if I look at this big side, 7.2, A prime to B prime, that's 7.2 divided by 2.4, which that is going to give me 3, I believe. I've got 7.5. That's A prime to C prime. That's the bottom one. Sorry for going out of order. 7.5 over 2.5. What do you know? That also gives me a 3. We're trying to be consistent, remember? And then 5.1 divided by 1.7. And that also gives me a 3. So this is the second way to see the scale factor, is that those sides get tripled. Remember, the sides are tripled, and these distances through that center of dilation are also tripled. Okay, so two different things get blown up, but the angles, those things stay the same. So looking at this specific example here, it tells me that the center of dilation is all the way back here. We call that the COD, center of dilation. Call of Duty fans out there. And then scale factor is 4, so everything should get quadrupled except the angles. Remember, those angles stay the same. So if Z to A is 11, what should Z to A prime be? That should be 44. It should be quadrupled. Okay, multiplied by 4. So we've got angle CBA, C to B to A is 50 degrees. 50 degrees right there. So C to B to A should also be 50. It stays the same if it's a dilation. It's 50 degrees. It's the same. Okay. We want to know that. So A prime to C prime, that's all the way up there at 24 right there. So then A to C should be, should I multiply by 4? No, I should divide it by 4. Divided by 4 to give me 6 centimeters. Okay, 6 right there. If we go down, that means it's a reduction. So ZB, that distance is 12 right there. So what is B to B prime? So kind of throwing you off a little bit. We know that this whole distance has to be 12 times 4, which is 48. So I bet you a ton of people would have been like, oh, boom, no, it's 48. It is actually not 48. It's going to be 48 minus 12, which will be 36 centimeters.